Alrighty guys, this is 7.1.2. We skipped 7.1.1 because we don't have the materials to give to you guys for it. Okay, so in your notebook, 7.1.2, that is the section that we're on. Chapter 7 really ties in everything that we've learned. So we're going to kind of go through that pretty quickly. 7.16. Right, so Dana's training for a bicycle race. He can ride 25 miles per hour. This is the rate. One day when he'd been riding 3/5 of an hour, he stopped to fix a flat tire. How many miles had he ridden when he stopped? Okay, so first thing you want to do is think about what your answer could be. What would be a reasonable answer for this? Okay, before you even solve. Don't do any math in your head. Just think. Okay, so 3/5 of an hour, that is not even a full hour, which means you are looking for a number that is less than 25, right? Because 25 miles would be 1 full hour. We are not at a full hour, so you will not be at 25, okay? But I'm sure it'd be more than 0 miles. Okay, so something in between there. If you do the calculations and you get something ridiculously large, then you stop and you go, oh wait, this does not make sense. Let me try again, okay? So they use the diagram. So this is for the rate is 25 miles for 1 hour. The rate is 25 miles per hour, 25 miles for each hour, 25 miles for every hour, right? And that's how you know your rate. This is our unit rate. This is what we use for everything, the number that we love. Okay, let's use the diagram. So this is how they drew the diagram. 25 miles for 1 hour. Right? But then they stopped for 3/5 of an hour. So what I'm going to do is I'm going to divide my line into fifths. Right? So a little one in between there, and then dividing those in half. I now have 5 spaces. Right? Spaces, not lines, spaces. Okay? So this part is 3 out of the 5 spaces. And what I want to look at, so copy that down, and then I'm going to cover it. Don't worry, don't erase. Then I want to look at how much is each of these spaces worth on the mile side, because I did the time. Now I'm looking at the mile side. There are 5 spaces. There are 25 miles total. So what do I do to find each space? I take 25, divide it by the 5 spaces, and that means that each one is 5 miles, right? So this is 5 miles. This is 5 miles, 5 miles, 5 miles, 5 miles. Okay? And the total is 25. We're talking again about spaces and not lines. You guys keep making the same errors. Okay. Now I look at the 3/5, right? So this 3 out of 5 on the bottom for the hour, right? If I have 3 sections out of the 5 for the miles, that would be a total of 15 miles. Okay. So this is how far he would have gone. And then you ask yourself, is that reasonable? Right? So 3/5 is a little bit more than half. So is this a little bit more than half of 25? Yes. Good job. Say good job, Miss Jan. Okay, 17. Again, pause, rewind if you think this is going too quickly for you. Okay. 17. Matt thought about the problem that we just did and drew the diagram at the right. Right? So think about how he's thinking about this problem. All right, so 7-17. Part A, we're only going to do part A. We'll talk about part B. Okay, the equation he uses. So one thing I don't like about this is because when we talk about scale factor, because they're using scale factor. Let's write this down. Scale factor is the new over the old. Oh, look, still ratios. This is your multiplier, right? So once you find this scale factor right here, your multiplier, you can find any side. One thing I don't like about this diagram right here is that your sides have to be the same, right? So if this part right here, the distance is 25 miles, we would multiply by the scale factor to find this part of the triangle, right? To keep it the same, right? Then what you would do for the other ones would be this one. You could just look at this. You don't have to draw this. Right? This side would be for the x if you multiply by 3/5. And then the last one, this side, would correspond with this one. Right? So it's matching, right? Your longest side with your longest new side. It's all about shrinking or enlarging it, all at the same rate. Okay? So equation, right? So we just do what they wrote. 25 miles times 3/5. This will give you 15 miles, right? So same thing. Let me break it down for you. Okay. 25 times 3 would be 75 miles. Sorry, 75 miles. Divided by 5. 75 divided by 5 would give you 15 miles. So 2 ways that you can do that. And it's the same thing, right? Still using that scale factor, still using that rate. Okay. Cool. Okay. So 2 different ways that we've used it, right? So the first time we use this 3/5 as a time, right? That's the hour. Here we used it as the scale factor, right? So going from one to the other to figure out the new. Both of these situations resulted in equivalent calculations, right? So how else can this be written? So 718, right? I want you guys to write this down. 25 times 3/5 equals 15. Okay. Part A, right? So using the portions web at the right, work with your team. Sorry, you don't have any team. You just got me. To find 2 other ways to write the equation. For example, one way might be 25 times 6/10 equals 15. What's the difference here? Right? And why is it still giving the same answer? If you guys remember, this is just the opposite of simplifying, right? So we were like unsimplifying the problem. If I multiply by 2 over 2, remember, big 1. 3 times 2 is 6. 5 times 2 is 10. And that gives us 6/10. And did I change anything? No, because I multiplied by 1. This is the multiplicative identity, right? So it's keeping its same identity. You can multiply anything by 1, right? That means 2 over 2, 3 over 3, 4 over 4, 10 over 10, a billion over a billion, right? And you'll still get that same number, okay? So then we've got the fraction. We need a decimal. So 25 times, what would my decimal be? You guys can figure this out. Fun fact, it's how you say it, right? So 6/10 would be 6/10. This still gives you 15. If you have a calculator, you can test it out and see that it's the same. Percent, right? So how do you go from decimal to percent, right? How do you go from decimal to percent? To remember, you multiply this by 100, right? This will give you 60%. Will give you 15, okay? So many ways that you can write this problem, right? This could be a grade. You got 60% on your last assignment, and there were 25 questions. How many did you get correct? Something like that, okay? So that's part A. Part B, if you didn't already find out what percent would be equivalent to 3/5, we already found that percent, right? And then use this percent to write a statement in words and symbols that is equivalent. So your equation, right? So the words, it would just be 60%. This would be 60% of 25. Remember, I can switch them because our commutative property, oh, sorry, not equals, is 15. Those are your words. Use the idea of scaling to find the following values, right? So when we find a percent of a number, right, we're only finding a part of it, okay? So we're going to write this expression using either a fraction or a decimal and then find the result. I'm actually going to make you guys do this on your own, so do some practice problems. Okay, last question. Thanks for bearing with me. I don't know how to pronounce that name, but this person went out to dinner at an Indian restaurant. The total bill was $38. She wanted to leave a 15% tip, right? So you want real world math? Parents, if you are listening to this, make your kids figure out the tip every time you go to a restaurant, okay? So if you use the idea of scaling, what would she need to multiply by? So part A, 7-19, right? Our multiplier would be our 15%, right? How would you represent this as a decimal? This would be, you guys can figure this out. Tell me what the decimal would be. This would be 15 hundredths, right? So we're dividing by 100. right? Percents are always out of 100. And then the fraction, oh, we already did this. Fraction, sorry, this is part A. Fraction would be 15. Percents are always over 100, right? 15 over 100, and then you can simplify it, okay? Does it make a difference which representation, fraction, or decimal you use to solve this problem? Try it. Multiply with your fraction, multiply with your decimal, multiply with your percent. So does it make a difference? And then the last question, which one do you think will be easier? Fraction, decimal, or percent? Okay, part B, you should have figured this out because I said try it, right? How much should this person leave for the tip? And show your calculations. Now, I won't be able to check your calculations, so feel free to use a calculator and figure out how much tip. And remember, if you get some weird decimal, right? First of all, think about how much you should be tipping. 15%, that is less than half. So your tip should be less than half of the total bill. If you get a number that's bigger than 38, this is where you're getting scammed. Okay, so this is why we need to learn math so you know how much appropriate tip to do. Okay. So tell me what the tip should be. Okay, what you should have gotten is 15%. So easiest way on a calculator, 15/100 times $38. This will give you $5.70. And remember, money, we've got 2 decimal places, automatic rounding. If she changes her mind and wants to leave a 20% tip instead, how much will this be? Right, so same thing, we would write 20 over 100 times 38, or you could do 20/100 or 2/10 times 38, or you could do, what am I missing? 20%. There's a percent button on your calculator too, times 38. Okay. There are also tip calculator apps that you can download, but again, you still want to know an idea of how much your tip should be because sometimes fingers mess up. Right, so maybe you pressed the wrong button, maybe you added an extra 0 in there or forgot the decimal, so it's really important to know what it's supposed to be. And when you calculate this one, you should get $7.60 should be your tip. Okay? Practice some tip problems, and whenever you go to a restaurant, volunteer to calculate the tip. Okay? Thanks, guys.